This means that my polar coordinate, going from the Cartesian, my polar is r comma theta, in this case 2 comma pi 6. And that's my final answer. So what you should have already taken away is this coordinate conversion. Know how to do this coordinate conversion, know how to go from polar to Cartesian, and then from Cartesian to polar. And do know how to graph your polar coordinates on a plane. Alright, one other thing we need to look at, actually two more topics. First, we're going to look at rewriting equations. So if we have full equations in Cartesian form, we're going to rewrite this in polar. And the way we do that is we use the idea that x equals r cosine theta and that y equals r sine theta from our conversions above. So for this example, we have x squared minus 2x plus y squared equals 0. We're just going to plug in our x's and y's. If you want to try this on your own first, go ahead and pause the video. Otherwise, just follow along. So we have x squared minus 2x plus y squared equals 0. We're going to plug in the polar forms of x and y. We get r cosine theta all squared minus 2 times r cosine theta plus r sine theta all squared equals 0. We can distribute the square. We get r squared cosine squared theta minus 2r cosine theta plus r squared sine squared theta equals 0. What I want you to look for in these problems is a cosine squared, sine squared. We really like it when this happens. So I'm going to put these two terms together. R squared cosine squared theta plus r squared sine squared theta. I still have the minus 2r cosine theta off to the side equals 0. With these terms, now I want you to factor out the r squared. So we're left with cosine squared plus sine squared. Hopefully this looks familiar, because hopefully you recognize from your Pythagorean identities that cosine squared plus sine squared is 1. So this gives us r squared times 1, and then we bring down the minus 2r cosine theta equals 0. We end up with r squared minus 2r cosine theta equals 0. And that is your final answer. So if we're down to one trig function, we're happy. And in this case, we are with the cosine theta. Okay, let's try another example. Let's try actually going reverse. We're going to go from a polar equation to rectangular coordinates equation. We're going to rewrite 2r equals secant theta in rectangular coordinates. First thing I hope you would want to do is rewrite this secant in terms of sine and cosine. So 2r equals secant theta is the same as 2r equals 1 over cosine theta, which we can rearrange to be r times cosine theta equals 1/2. The reason I did that is I'm going to try to get either an r times cosine theta in my equation or an r times sine theta, so I can replace it with x or y. I'm going to try and manipulate my equations to get that. Since I have an r cosine theta, I can replace that with x. I get x equals 1/2. And we've gotten rid of our r and our theta. We're in terms of just x and y, so we're happy. That's my final answer for this problem. So quick summary. To go from rectangular coordinates to polar, you want to use that x equals r cosine theta and y equals r sine theta. To reverse the process, it's the same idea, but you're now going to try to make it so your equation has an r cosine theta or an r sine theta in it, so you can replace it. And then always look for this cosine squared, sine squared.